Cool. And I think we're still sharing screen. So I'm going to hide this thing. There we go. Okay. Hi, everybody. How are y'all doing today? Nice. That was super energetic. Love it. I hope you're doing as well as I am. Not to brag or anything, but we're going to talk about some really cool stuff today. So I'm super excited. So hopefully that'll make you excited too. Let me get into some announcements if it'll let me go. Whoa. Whoa. Uh-oh. Give me a sec. Where is the slide? There it is. We love technology. There we go. Let me make sure that, okay. I believe it's still sharing, but I'll do this just in case. All right. And we're recording. Okay. We'll try that again. Yeah, so I'm really excited to show you some really cool stuff today. Let's go ahead and get into it. But before we do anything, I want to refresh from last week just a little bit. Oh, I had these backwards. Sorry. We'll do announcements, then we'll refresh. Announcements. Please check out the Ultimate Plotting Guide and other resources. They will be super helpful for you in this coming up homework, this homework that you're working on, and the future ones. We have 3 of them so far up there, I believe, or 2 or 3. Basics of Python. If you're struggling and don't remember how things work, definitely look at the syntax for that. And then the Ultimate Plotting Guide is super, super, super helpful. I can't stress it enough how much you will reference it, and we'll talk, and I'll dedicate some time to open it up and show you what it looks like. It's uploaded to B courses. It's under resources. We love to see y'all at office hours. I saw some friendly faces at my office hours, and I believe some of the other instructors saw more of you. So we're always happy to have you at office hours. But don't forget, there's also a Piazza. I made some additions to the B courses. I realized it's hella late. My bad. I forgot, but there was the DeCal playlist that you all helped me make, and I actually figured out how to embed it on the web page. Just make sure you're not sharing via HDMI because you can't control the audio like volume, at least not on the web page. But if you don't have Spotify on your own, you can always just pull it up on the B courses and you can listen to it when you're doing your homework. I think that's a good idea. I also added an anonymous feedback form. If you have critiques for how the class is working, you don't like it, maybe you love it and you want to tell us how good of a job we're doing, you can let us know via anonymously. I hope you, if you feel inclined to use it, use it. We'll check it periodically throughout the semester. And if you have any feedback, we're more than happy to try and incorporate it. We can't incorporate everybody's feedback and critiques, but if we think we can, we'll do our best. Is there any questions about that? Okay, let's go. Now let's get into the recap for last week. So I just want to reiterate, because plotting is a huge part of sciences and really just any field where you want to convey information. And I really want to hammer home what Annie talked about last week. We had a little bit of a weekend to forget, so let's just remind ourselves. Someone once said a picture is worth 1,000 words. I don't know who that was, but someone said it. I know that. And it makes complicated ideas easier to understand. That's why we care about plotting. Plotting an image usually can convey way more information than like a bunch of paragraphs of like really hard to read science text or whatever. So if you can convey your information into one picture that kind of sums up everything, oh man, wow, that's beautiful. In fact, when I read research papers, like I read the title, the summary, and then I just go to the pictures. I don't even read the rest of the paper usually, unless I really need to understand it. But other than that, most scientists just look for the figures and try to understand the figures, and that tells you everything about the paper usually. That's how you should be writing science papers in the future. And hopefully we will, by the end of this course, you will feel very comfortable making plots and images of, or like figures that represent exactly what you're trying to convey and show the trends in your data. Plots are extremely useful. And I want to give an example. So we'll do a little example here. I just put a lot of stuff on the screen, so I apologize, but let's kind of walk through it. So on the left is a caption to this giant ass figure. Okay. This caption has a whole bunch of stuff that's really hard to follow. Versatility and power of TNG50 and combining high res blah 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 statistics. Yeah, it's a lot of reading. Look at all those like expressions and math and stuff. I don't care. Look at this. There's a galaxy in it. And there's a galaxy. It says, it's hard to read because you're so far away, but the left side with the pretty colors says column density in some units or whatever, gas column density, and the right one says stellar composite. That's another word for like the light. So just off of this, it's the same galaxy on the top. We see column density, or like how dense it is on the left, and the light that it emits on the right. All of that from that. They're like the same thing. And then this is just a bunch of different galaxies, and this is the side view. But notice how much easier it is to read something like this than it is to read something like that. This is why plots are super useful. Now, this is a super sophisticated plot. I don't expect you to plot anything like this anytime soon, unless you really want to. But just the idea of like being able to condense something so massive and so much text into just an idea on a figure is the essence of plotting. That's why we do it. So that you can see a point that you're trying to get across in your work. So now let's get into how we do that. Or let's keep recapping. Let's remember how we did it last time. Remember, we talked about how to make plot lines or how to plot lines onto a figure. We use plt.plot for that. That's the like smooth line. Or if you don't have enough points, then it's like a weird like piecewise line. It doesn't look good. But if you want to plot individual points, we use plt.scatter. That's what we talked about last time. You can put them both in the same figure. But I really wanted to kind of give you kind of like an idea of like kind of how it works. And I think this image will help you. I call it the figure sandwich. And this is what it looks like. So every time you make a plot, this is like the proper way to do it. You could skip a couple of these steps and you'll be fine. But this is like the proper way to make a figure. You always start the top of your sandwich with plt.figure, right? Everything in between is like plotting data, scattering data, adding like X limits and Y limits, maybe like legends and labels and titles, all that stuff that's like, just makes it look pretty or like makes it, like add clarifying stuff on it. All that is like artificial stuff. That's like all the non-essentials in the sandwich. And then the bottom is the plt.show. You need the plt.figure and the plt.show to like be a full figure. You can omit those two lines and it won't break it or anything. But in the background, matplotlib is putting them in for you anyway. But this is technically what you do. You make the figure, you add to it, and then you show it. That's it. And every line that you put in between is how you add to it. And there's hundreds of different lines you could add to it. I mean, oh my God, I'm not going to go through every single one of them, but probably thousands. So there's like hundreds of thousands of lines of code that are available to you. And if you really are curious, how do I make this blah, blah, blah on this plot? You Google it and matplotlib, I guarantee you there will be somebody who had the same question and did it. And we'll give you an example of how we go through, like, how do I make this? How do I do this on plotting? Like a little bit of a spoiler alert, the ultimate plotting guide kind of has like everything you could ask. But if you have some niche question, you can always just Google it too. But when you put all those lines together, you get something that looks like this. It's on the right. A simple figure, just one plot with maybe some lines, some data points, and that's about it. And there's different functions you can use to like do histograms inside of it, or you can do like whatever, but those are the basics. That is the absolute basics of matplotlib, the library that we use to plot data. Is there any questions about that? Okay, if there's no more questions about that, then let's do a small group question. So what will we see if I wrote the following code? Assuming we already wrote what x is and f of x and g of x earlier in the code. So maybe x is a linspace and f and g are like functions that we use. What happens if I write plt.plot x comma f of x and then plt.show? And then below that, I do plt.plot x, g of x, plt.show below. So discuss with like people around you at your table, maybe next to you or the people at the table. We'll spend about 3 or 4 minutes on this and then we'll come back, okay? So yeah, speak freely. And then for the folks on the Zoom, I'll make a breakout room for you. Have fun in the breakout room, folks on the Zoom. Okay. Come on. All right, like 10 seconds and then we'll reconvene. All right. I think we're still showing our screen and everything. Okay. Does anybody want to volunteer to answer this question? Yeah. That's a good thought, but there is one thing that makes that not happen. So if we go back to the sandwich, notice how at the end of the sandwich we put a plt.show. So if you put a plt.show before you put your next plt.plot line, it cuts your sandwich off. So it's the equivalent of like, yeah, it's like cutting your sandwich off. So this makes one sandwich and this makes another sandwich. So that's kind of why it's important to like give yourself a plt.figure and a plt.show to like kind of create the sandwich so you know, okay, this will be plotted inside of this. And if I put multiple plt.plot lines above the plt.show, then they'll show up on the same figure. But if I put a plt.show in between them, we actually create two different figures. So one figure will be x or f of x versus x, and then the next one will be x or g of x versus x below it. It'll create two separate figures. And that's what we're going to talk about today is how do you do that more thoughtfully? And how do you make it so that you make it exactly the way you want? A plot like this, for example, is putting several figures or several plots next to each other all in one giant figure. We call that idea subplots. So we'll talk about that today with more advanced plotting. So last time we talked about the very basics, and just now we talked about the basics a little bit more, kind of giving you that sandwich idea. But now we're going to really take this idea and run with it. And it's important that we know how the sandwich works when we want to put lots of sub sandwiches next to each other. Like I was trying to do a Subway joke, but it didn't work. Yeah, so we're going to get into more advanced plotting. So how do you make subplots? How do you put lots of pictures next to each other? How do you make three-dimensional plots that look really cool, like the one up here? I don't know if you can see that. The little sine waves in 3D space looks pretty cool. Contour plots, you know, showing like lines of constant density or whatever the third axis might be. Histograms, polar graphs, you name it. Matplotlib can literally do anything that you can imagine in a figure, but it just takes a little bit of work and finagling to try and figure out exactly how to do it. But these are all possibilities that we can play with, and let's get into some of them. Before we do anything, we should understand the subplots and how they work, and understand the overall framework for Matplotlib. Because once we understand how subplots work, it'll make it a lot easier for us to do the more advanced stuff. So in order to make subplots, we need to understand what's happening behind the scenes. So a plot like this, where it's kind of hard to see the borders, I apologize. It's like an old plot. I should probably replace this. We see, so I can narrate, the top left is winter, the top right is spring, bottom left summer, and bottom right autumn. And these are 2012 to 2013 seasonal temperature observations. So this is just a bunch of data lines that represent how temperature changes throughout the seasons. Each one's a different season. Not so important what it is, but it's nice to have 4 different figures that are kind of separate, their own distinct things. Now you can capture the same information by just putting them all on the same plot and having different lines, but then you lose the idea of like dates and times. And some cases you do want more figures, some cases you don't. It really is completely a user dependent idea, and it's a way to express yourself. So being able to have this option in your back pocket is useful. To understand how Matplotlib makes these figures, we have to distinguish what I mean by plots and figures. So Matplotlib, the way it works, imagine you have a giant canvas. It creates a canvas. We call this the figure. It's like the overarching box. It kind of everything gets thrown into. Now, when you do plt.plot without putting anything else there, it creates a figure for you, and it says, I'm going to put one plot on that figure, and that's it. And it just does it for you, so you don't have to worry about it. This is to be user-friendly, the quick and dirty way. But you can be a lot more specific with how Matplotlib divvies things up. Maybe you want to have two separate plots in the same figure. The figure being like the overall overarching canvas, maybe, and then the different plots might be like panels on a comic book, for example. These are different plots that we can put inside of the entire figure. They're like sub pictures, you can think of them. Any questions about that? Okay. Now let's discuss how the two approaches work in Matplotlib. So the state machine approach is the one that we taught you last week. That's the most basic way to use Matplotlib. It offers very little flexibility and control compared to the object-oriented approach. And I'll get to what that is in a second. So just remember, it's like the figure sandwich, right? We do plt.figure, plt.plot, maybe some other stuff, plt.show, and that's the sandwich. That's it, and it'll make one plot for you. That's it. That's good and all. It gets you quick and dirty, but it's not useful when you want to make really sophisticated figures that are ready for like a publication, for example. To do that, we go to an object-oriented approach. And this is the idea of creating an object that you can modify inside of Python. So think of the axis or the plot, this one, like these little plots that are inside the figure, you can change them. So think of this ax object, fig, ax. Ax is an object that Matplotlib creates. That is the equivalent of that little subplot. And then you can modify it. You could say, okay, now plot the data to this axis object. Add an X label to this axis object. And that gives you the ability to specify the difference between plot 2 and plot 1. So you can basically only talk about plot 2 and leave plot 1 completely empty, and you can give it all the fancy details, and then you can worry about plot 1 later. And the way we do this, just explicitly, you do fig, ax. Fig, we're assigning two different variables. Fig is the actual figure itself, a figure object, and ax is the axis object inside of that figure. You can make multiple axis objects, maybe like ax1, ax2, ax3 for 3 different subplots by changing the parameters inside of this plt.subplots function. So the subplots function, the 1, 1 says I want 1 row and 1 column of plots inside my figure. 1 and 1 makes only just 1 plot. It's the same thing. These two are exactly the same. They'll give you the same exact result. But this way allows us to be a lot more flexible and create more sophisticated ideas. So 1, 1 is rows and columns. That's it. Ax.plot, we just add plotting data to the axis object, just like x or like f of x versus x, and then we show it. Now, like I said, this allows us to make multiple plots efficiently, and once they're created, we use a slightly different syntax. So you'll notice certain things don't work the same. So if I want to do like plt.title, for example, it's a little different. In this axis object one, it's plt.set_title. Or not plt. It's ax.set_title. Usually there's like a tiny little difference. And if it doesn't work, Google it. Or just check the DeCal ultimate plotting guide, and it'll make a lot more sense. And now let's just do a nice thorough example. This is the subplot syntax. You do your standard x is equal to np.linspace, creating 100 data points evenly spaced between 1 and 10. 1 being the start, 10 being the finish, 100 being the number of points. Then y is equal to np.sign of x, just like a normal function. Then now we get into the new stuff. Figure or fig, ax. We're assigning a figure object and an axis object from the plt.subplots function. 1 row, 1 column, so it's only 1 plot inside of our overarching figure. Then we do ax.plot, x, y, and this just plots the xy data. And then you could do, for example, ax.set_title and put a string in, that's the title. Set_x label, set_y label, and then plt.show. Notice the set underscore. It's like a small difference. It's the same idea. It's just the syntax is a little different for this object-oriented approach. We're creating an axis object. That is the object-oriented idea. And we're modifying that object with different lines. And remember, there could be tons of different like modifications you can make. I can't go over all of them. That'll be for you to Google and play around with. How do I add this to an axis object? You have a question? No, that's a good question. There is none. And the reason for that is because we really only run into like scope issues if things are nested inside a function. So this isn't nested inside of a function at all. This is all like global. Everything here is in global space. But if we had maybe made a function, call it like make my pretty plot or something, and it like we put all of this information inside of it, and we just wanted to put in like maybe your argument is X and Y data, and you wanted to do it that way, then you can start running into some global local issues. But usually you won't have to deal with that with plotting most of the time. As long as you just keep it in the outside of functions, it's fine. Any other questions? Okay, let's move on. So that's subplots, and we can do the same thing with like, it doesn't just have to be like those one like lines or data points on top of a plot. We can use tons of different types of plots, and I want to get into some of my favorite kinds. So these are like 3D or 2D plots, however you call them. We have an X and a Y like positions, and then outside of the color that you assign to it is like the third dimensional value. So I call them 3D plots, but there's also really 3D plots that you can like rotate and stuff. But this is like a very common way to visualize three-dimensional data. And we use a function called IMShow. So this is another matplotlib thing. It's just like plt.plot or plt.scatter, but this is .imshow now. And this is its own function. It allows us to plot a matrix of data. So so imagine you have like a 10 by 10 grid or something, whatever this is. It's a 2 by 2 array in like NumPy. We have that two-dimensional array. This is where they're useful for. And they have different values assigned to each cell. How do I plot this? Maybe I have some values that are like ones and zeros, and I want to see which ones are ones and which ones are zeros. Like a checkerboard in your homework. Oh, spoiler alert, we're going to talk about that. You can make pretty plots that look like this. Like, well, kind of boring, but it'll get interesting, I promise. So we can plot like three-dimensional functions using this IMShow, for example. And it's a little complicated to understand at the very beginning, but I'll try my best to walk you through it. So up there at the very top, x comma y is equal to np.meshgrid, right here, this line. This takes in two lin spaces, your x and your y data. So we're saying I want my x data to go from -1 to 1, and my y data to go from -2 to -2 to 2 with 100 evenly spaced points. Now, normally these are just two one-dimensional arrays, of different values. But I want to make a grid of arrays. Say I want to have x comma y at every single point. This mesh grid function combines them and gives you two arrays, x and y, that you can use. They're the same array. They're just two-dimensional now, and they have the full grid of values. Okay? So x and y, now you can just treat them like they're as if variables inside of a function. This is the whole point of why we do it this way. It's just so it's easier for us to use with NumPy. So this mesh grid creates this really nice kind of like grid mesh that you can plug into your functions for x and y values. So if you do f is equal to x plus y, you'll see something like this. This is like a characteristic of f is equal to x plus y, this function right here that we're plotting. And if we want to plot that data, we do plt.figure, make that figure sandwich, plt.imshow, where we're plotting an array. F is an array. It's a two-dimensional array of different values. And then we have a color map. We can choose lots of different color maps. I'll explain that a little bit more later. But different choices of color map means different color mapping values. So this one, I think I chose one called hot, which just has a bunch of like reds and yellows and blacks and maybe white a little bit. But maybe you want one that's all blue, that different colors of blue. Maybe you want one that's rainbow. There's tons of different color map choices, and that'll be outlined in the Ultimate Plotting Guide. So you can check that out later. And then we can set like maybe the origin equal to the bottom left. These are like different arguments that you can look up in your own time or check the plotting guide and see for yourself. I'm not going to go through all of them. I'm just giving you the gist idea. IAMShow takes in some array, and you can modify the parameters to make it just the way you want it. And then we add a color bar, plt.color bar, and that creates this color bar here to tell you what the colors mean. So black represents -3, white represents +3. And since we start 0, 0 on the bottom left and go all the way to the top right, we see like we expect that the top right is x plus y. That should be the biggest value, and the lowest value should be x plus y 0, 0. Perhaps the figure might be a little long, but it's fine. It's not important. What is important is that you can color values with a color map and make and represent them like this. Is there any questions? Okay, we'll keep going. Here's another example. Maybe you have some data, checkerboard data. You might have seen this in your homework. If you make an array that looks like this with 1s and 0s like that, then we can have some fun with it. We can just straight up plot that array. It's a 2-dimensional array. You could plot any 2D array with IAMShow, and it'll look like this. This is black and white. I chose the color map, so it's black and white, but that's that. If you don't know what the np.load text is, I recommend going back a lecture and watching it just to see what I'm talking about. Well, that's just a way of loading in data. And in this case, checkerboard data is just this 2D array that you can see on your left. And we just plot it. Pretty cool. So IAMShow is a really useful thing. And if you want to use it, and if you want to use it in the figure or object-oriented approach, you just do ax.IAMShow instead of plt.IAMShow. Go ahead.
For the previous example, so IAMShow is taking a 2D array or a 3D array, because you have the x and y, but then you also have the assigned value, like the third dimension.
Right.
You're just passing f, so is it a 3?
Right. Yeah, so it's a 2-dimensional array because every x and y pair, or like if you index into a 2D array, you have 2 indices to work with, like rows and columns. Every row and column value that you choose, say the 0th row, 0th column, that'll be the very top left of the array, for example, that has a value in it. So in this case, I chose it to be a 1 or a 0 or a 1 or a 0. So 2D arrays can be represented here. Similarly, if I had like something like this, then that top left value might be like 7.2 or whatever. The next one might be 7.3 and then whatever. But it's still only 2-dimensional because you only have 2 axes to go on. 3-dimensional would be out of the page. So like you literally need a volume to represent what you're looking at. Does that make sense?
Yeah, but I guess I don't see. So f, the function f over there, has the value of added positions, x and y? Or...
So yeah, we assign like the x and y, you can literally think of them as their x and y coordinates, but we're just adding their values. This figure I think is a little long, but the way NumPy works, remember, is that broadcasting. So if you have 2 arrays that are the same length, maybe a bunch of numbers and a bunch of numbers, instead of when you add them together, it's not like a list where it just makes a longer list. It literally adds each value to each other, and we call that broadcasting. With 2D arrays, imagine you have like 2 grids and you lay them on top of each other and you add all the values on top of each other. That's what f is. F is this. It's a 2-dimensional grid, like a sheet with x and y values added on top of each other. Does that make sense? Okay. So at every x and y pair, there's 1 value, and that's why we represent it as a 2-dimensional array. Okay. So let's move on. Let's keep going. So these are some more examples of 3D plots. So, or 2D, however you wanted to call it. What I just showed you with IAMShow. You can use IAMShow to make some really cool stuff. On the left is some fractals, if you're really into math. In the middle is the actual data of a silicone atom or something, a surface. I got this from another class. I thought it was cool. It's like literally the surface of silicone in units of nanometers or whatever. Maybe you want to plot some really pretty functions from like your calculus class. If you're taking multivariable, or you are going to, you can use this to visualize your functions, make some pretty cool stuff. I believe in the homework coming up, I have some really fun. I think I chose functions that make like a pinwheel, and I made one that make like a triangle shape or something. It'll look really cool. But yeah, so that's just some examples that you can use these plots for. Yeah, and I want to go through a demo really quick using this. So we'll go ahead and open up. I sent out an announcement. If you saw it, or if you haven't seen it, there's some files on B courses. They should be under lecture demos, advanced plotting. You can download them right now if you don't have them already. They are files, lecture demos, advanced plotting. You feel free to download everything here and put it in the same folder wherever you know how to access it through your Jupyter notebooks, and you'll be able to follow along. But for those that don't have those, we'll go through here. So let me make sure I make this bigger. Let's go ahead and do some demo time. Okay, so let me pull up. I want to make sure I don't mess anything up for y'all. Okay, so anytime we do coding, right, we always have our import statements. By now we're comfortable with this. Always import numpy as np. Always import matplotlib.pyplot as plt. This is like very standard. Anytime you want to do science, you're typically going to import these things. This little percent matplotlib inline is just a way to make the Jupyter notebook plot the figure nicely, cleanly. You can have it be a different thing and it'll make it more interactive where you can actually like click and move the data around and all that. We can talk about that afterwards if there's time. But inline is just it's just a parameter that make it look nice. So starting simple, let's go ahead and use the knowledge we got from homework 2. If you haven't started it, well, here's a little bit of a solutions manual, I guess. But we're going to make a checkerboard pattern. So the way to do that is create array. Can everybody see this in the back of the room? Clearly, read it. All right. So we're going to start with a giant array of ones. You can also start with zeros, but I like to start with ones. And we're going to set it to be 8 by 8. This is just some arbitrary setting I chose. I want it to be an 8 by 8 array. So 8, 8 in the little tuple makes the shape. And then I want them to be integers. This is not, I didn't spell that right. Don't worry about this. You don't really need this, but all I'm saying is I want the ones not to be floats. I want them to be integers. That's all that parameter is. Uh-oh. Let's overwrite it. Cool. All right. Hopefully that didn't break it. And then we can index those values using our slicing and indexing tools that we've developed previously. If you don't understand how this works, check out the homework or come to office hours and I can help you out. But we're essentially skipping every other value. That's what this 2 is. It's saying I want to start at like 1 and skip every other value. And then this one starts at 0, skips every other value in the X and Y axis. Then we do the same again, just like so. And we set those values equal to 0. So every other, basically in a checkerboard fashion, it'll set certain values equal to 0 that we want. And then we can actually print the checkerboard and see what it looks like, just to make sure we did it right. Oh, I got to import. Silly me. Can't believe I forgot that. There we go. So now you have an array that looks like this. So we use that slicing and striding approach, as we call it, to set certain indices equal to 1s and 0s, or in this case, 0s, because we already made everything 1. And now we have this really nice like array to work with. And we can plot it. So this will be super easy. We could do plt.figure to make our figure sandwich. And we'll do plt.imshow. I'm doing the quick and dirty version here. And with this plt.imshow, I'll just give it the array. And I will plt.show it. So figure creates the figure, imshow makes the array or plots the array, and show displays it to me. Ah, that's a checkerboard. It looks kind of ugly though. I don't like those zeros and numbers on the sides, and I also don't like that color scheme. That's not a checkerboard, so I can change that. Here's an example. We can change the color map, CMap for short, equal to something else. I just happen to know this one works because I played with it. We're gonna change it to hot. That'll make it black and white for us. And then I also don't like those tick labels. So let's get rid of them. You can set, this is just some parameter. Again, check the ultimate plotting guide to like see how it works. But X ticks is something that I can modify to change the X tick labels. Same thing with Y tick labels. Y ticks like this. And we could just give them empty lists to make those numbers disappear. That's just a trick. Don't worry if you didn't like follow along super well on that bit. It's not super important, but it's just little things that I could change to make it look different. And now you see it's a different colors and the numbers are gone. So there's little, little tricks you can do to make your, or little modifications you can make to the axis object inside of the figure. But we're doing state machine approach, so it's a little different. But anyway, little modifications you can make to this figure to make it look cleaner or make it how you want. And all of that stuff can be seen when you Google, how do I do this? How do I remove X tick labels? I promise you, you'll find something that's somebody wrote that makes your life easy. You just copy and paste the code in there, or you can check the plotting guide. I can't plug it enough. It'll help you. So that's really cool. That's how we plot like data, for example. And this is just a small array here, but maybe you had a really big array, or maybe you're a nerd like me and like to play Minecraft. Oh, and took the time to figure out how to plot it on matplotlib. Yeah, whatever. Anyway, there's lots of cases where you can actually use real data. Okay, we could plot continuous functions. Let's just make sure that we get a little example of this in here. So the data of the function we're going to plot, I'm going to do like sine of x, y plus cosine of x, just some random function. Before I do that, let's go ahead and make our x and y data. So we'll say x comma y is equal to np.meshgrid. Remember, this basically, it's like interpolating the x and y arrays that we give it. We're going to give it an array of x values and an array of y values, and it'll just combine them to make a grid of those x and y's. So that's what these two lin spaces are going to be inside of here for. So this is the x. We'll set it -10 to 10, and we'll give it 100, or yeah, we'll give it 100 values. I think that shouldn't be too slow. Remember, the more points you put in here, it's squared. So if you put 1,000 points, it's 1,000 points squared total there is in the entire array, because it's two-dimensional. So just remember, don't make this like 10,000 or something. It might get a little slow on you. But I think 1,000 should be fine. So we're just going to set x and y to be from -10 to 10, 1,000 points each. Ooh, I don't want to take a screenshot. Okay, so there's that. And then we can just make a function, or we can like create an array f where we just do like some function like sine of x times y plus maybe like np.cosine of x. Here's a good example. And then we can plot that data. So remember, plt.figure, plt.imshow, and plt.show, the sandwich. Figure and show is the sandwich. Imshow, we can just plug in f right away, and it'll make something that looks like that. Oh, it's pretty cool, right? Yeah. You can change the color map. My favorite ones are like ones with red in it, just because I don't know, it's my favorite color. So here's one called Inferno that I found. Looks like that. That's pretty cool. You can add a color bar because I don't know what these colors mean. You'll see the color bar, just like that. Just add a little color bar inside the sandwich. And if we run that, boom, it makes the colors assigned and stuff. That's cool. And you can add like titles and X labels and Y labels, just like before. And in fact, you can actually make you can do this the axis object oriented away. But I'll come back to that because I really want to make sure that I get to the next thing. I don't want to run out of time like I did last year or last semester. So this is how you plot like an actual function. Here's the like 4 lines of code it actually took to do it. But now what if I really want to play with some data? So this is the fun part of the course. This is why it's Python offered from astronomers. So check this out. It's a telescope orbiting the Earth, going really, really fast, like tens of thousands of miles per hour or something like that. And it's got a camera on it, and it takes pictures of space, like really cool pictures. And maybe I want to pull an image from NASA's archives from the Hubble Space Telescope and plot it and see what it looks like. What does my space look like? Let's do that. So there should be like an astro underscore CSV file or astro image CSV. So we have a little experience loading in data files, mp.load text, for example. This is a CSV file, so it's comma separated values. It's just like that's what it stands for. So you set that delimiter equal to comma usually. So let's load that data in. So I can say image data is equal to mp.load text. We learned that last time. And I believe I just have it right there. Image.csv. Limiter, did I spell that right? Is equal to comma, like that. So that gives us our image data. And now let's plot it. plt.figure, make that fig size. Well, this is a parameter you can put into the figure. And we can make it, make it really big so it looks nice. Just takes in a tuple. 12 is the width, 10 is the height of some weird units. We had that question a while ago. I don't really know what the units are, but there's something in your screen ratio wise. We could do plt.im show. Just plot this data. We'll do image underscore data. And then I like a CMap equal to hot. The color map is hot. I think it'll look really nice. And then I just know this ahead of time because I've played with the data, but I'm going to set the vertical max value to be 50, or the vertical minimum value to be 50, and the vertical maximum value equal to 400, just because I know what the data, this is just me. This is like when your professor says, we'll make an ansatz, because we know the answer. Don't worry about that. You'll be able to come up with that on your own when you're playing with your own data sets. But we'll add a color bar, and then we'll add an X limit of 1600 to 0 to plot it backwards. Little tricks that you can do with matplotlib. Again, it's all in the plotting guide. Don't worry if you didn't see that. Oh, I think I accidentally, I think I named this CSV, but I didn't actually make it a CSV. That's silly me. Okay, that should work now. Yeah, look at that. Look at that plot. Wow, does anybody recognize that image? Yes, it's space, but these are like the 3 pillars, like it's a very common image. It looks pretty cool. Wow, yeah. Oh, yeah. All right, let's make it a different color though. You want to make it blue? All right, well, let's make it colors of blue. Oh, wow, look at that. That looks pretty cool. There's also some really ugly color maps you can choose from. Like, there is a yellow one, but there's one that's like, is it winter or cool? No, I think that's like the ugliest color map I could have possibly chosen. Inferno? Yeah. Let's play with Inferno. Whoa, oh, that does look pretty sick. Yeah, so that's pretty cool, right? So this is real data that is taken with a telescope. I can't remember, I don't know how long it was taken for, probably like a 20-minute exposure or something where you just let the camera collect light for 20 minutes. And it's orbiting in space, so there's no atmosphere it has to look through, so it's not blurry. It's pretty dang clear. I don't know what the scales are on the X and Y axis or anything, but nonetheless, it is pretty nice. It's a pretty nice example of how you can plot real data. And on the y-axis, I believe we have like number of photons that hit the CCD or something on this color bar. That's what it means, like physically, which is pretty cool. And then lastly, we can play around and make subplots. So I actually never showed you how to do it with like multiple plots in the same figure. So let's do that. Let's do X is equal to np.linspace. I'll zoom back in. Hopefully everybody can see that better. And we'll go from like, 0 to 2 times np.pi, which is just 2 pi. And we'll do like 100, or we'll do 500 points in between, maybe. And then we'll set 2 different y lines, maybe like np.sine of x. And y2 is np.sine sine of x plus some random noise. So we're just using NumPy's random library, and we're sampling from a uniform distribution, like 500 points. So we're just adding this. This is just adding random noise, just some random data to it, and then we can make the figure by doing f or fig, right? We're making the figure, and then now since we want to add two different lines or two different plots, we need two different axis objects. So we'll say x1, x2 inside of a tuple. So since we're going to assign two different plots or subplots inside of our figure, we're going to do one row and two columns. So it'll be two plots next to each other. And since we're doing that, we have to have two axis objects be spit out. Okay. And then I'll just make sure that the fig size is nice and wide so that we don't have like scrunching. And then we can change these ax1 and ax2 objects as we please. So we can ax1.plot some data. Maybe you want to do x and y1. And then we can do ax2.plot x and y2. And then don't forget to add your qlt.show. So ax1 is going to plot just the clean sine wave, and ax2 is going to plot the noisy sine wave. Wow, and now you see that. That's pretty neat. And we can add multiple lines on top of ax2 so that maybe you want to see what the original sine wave looked like. It's kind of hard to see, but you can see that like orange line. Maybe we can change the colors, adding a color parameter. I know it's just like annoying when there's like tons of different parameters I'm throwing at you. But again, they're all in the matplotlib ultimate plotting guide notebook on the B courses, and you can just reference them. But now you can see the original data is in the black, and the red is the noisy data. And the reason why it's like different, like you can notice that the Y scale is different, it's like a lot bigger because the noise is a lot bigger. But we can make it smaller. For example, we can divide by 6, and now it's a reasonable sine wave, for example. Okay, so now we have two subplots, and you can add titles and labels to each of the different axis objects. Maybe I want to do ax2.title or set underscore title noisy data, and then I want to do the same for the first axis object, but we'll do clean data like that. And now you can distinguish which plot's which. Okay, so this is subplots inside of the entire figure. And remember, the figure itself is fig. Is there any questions about that? Okay, if not, then I'll see everybody on Wednesday. Thank you for attending. Don't forget the homework will be due. What's up? I'll stop sharing and stop recording.